Welcome. In this tutorial, I will demonstrate how to simulate cloth over a picnic table, a table with a rectangular surface. We begin by drawing a rectangle for the cloth to represent the tablecloth. We group it and position it over the center of this surface and a particular distance above the surface. We then assign a collider type to the table and a cloth type to the tablecloth. Now what we want to do is apply a grid to the tablecloth. We first use a line tool to estimate a grid spacing. It seems like we would have to adjust our units to centimeters, and now we can estimate. So it seems like 3 or 4 centimeters is a reasonable spacing. By saying reasonable, I mean that the resulting grid resolution will not affect performance too much, and neither will it give us poor quality result. To apply grid, we access the ClothWorks menu, click on one cloth, and either apply simple grid or smart grid. Here I choose smart grid and set the padding or spacing to a reasonable value. Here it is already set to 4 centimeters, which is reasonable, and we press OK to have it generate the grid. Here we have a grid. Now we can press play to see what happens. As you notice, the cloth overlaps itself and the edges. This is because we have not enabled the self-collision. In order to fix this, we have to reset simulation by clicking this button, reset button, and then opening the ClothWorks UI, selecting the cloth, clicking on the Object tab on the cloth section, and then enabling the self-collide option. You can also enable drag if you want to, but this is not important. Let's press play again. There you notice that cloth is no longer overlapping itself. Now we run simulation, or have the simulation run until cloth reaches its equilibrium. We can also help it do this by increasing the viscosity. But here it's already almost at equilibrium, so we don't have to do anything. And we also may want to adjust the stiffness. But that's not necessary. If you wanted to have the bending over here to be less noticeable, it would have been better if we perhaps increased the increased the grid resolution by applying a smaller grid. So here I would apply a new grid. Well, first I have to reset and purge the edges. There's no more grid, and then apply a new grid. Say with a 3 centimeter spacing, which does take more time to generate. Here's a smaller grid. Now we can press play and see how it goes. I would also increase viscosity a little bit to help the cloth reach its equilibrium. have the simulation run until we find a good stopping point, and or either when cloth stops moving, and then we press the stop button to preserve the layout, and of course end the simulation. Now what we want to do is apply subdivision and Laplacian smoothing. Seems like it would be reasonable to first apply Laplacian smoothing to regulate some corners over here. One iteration would be fine. One iteration, and then follow with loop subdivision. We could have also done the other way around, but the Laplacian smoothing after loop subdivision has smaller effect, or less noticeable effect than applying it prior to loop subdivision. We can also apply Laplacian smoothing again to remove the rounded corners, say with 2 iterations this time. There. And this is how the cloth looks. To finish the cloth, we now would want to apply the texture, and to do this we click on the toggle drape icon first. This will reset the layout of the cloth. Then we enter the context of the cloth and assign it a desired texture. And click on this icon again to renew the layout. There. This completes the tutorial for draping a picnic table. Thanks for watching, and see you next time.